was put forward by a German weather scientist, Alfred Wegener.
Okay, so you'll see this a lot in like pop culture type documentaries, and this is a decent documentary. But did he put forth a theory? What did he actually put forth? What comes before a theory? A hypothesis. Very good. So if you've got a little bit of evidence, you might be able to, and this is what Wegener did. He had a little bit of evidence that was shaky at best. And he said, here's my idea. It's a hypothesis that these continents maybe weren't always where they are now. Maybe they've moved. And the geologists of the time said, you're nuts. That's impossible. So he stuck with it. He wasn't able to prove it. Well, if you're not able to prove it, is that a theory? No, it's a hypothesis at best. Now, later on, other people were able to prove it. If you start off with a hypothesis, what do you need to do to it? You need to test it. How many times? Once?
No.
How many people need to test it? One?
Yeah.
No, multiple people. Scientist's job, experimental scientist's job, when they're confronted with a new hypothesis, your job is to try to do what to it? Prove it right or prove it wrong? I mean, really, how do you prove something right? By having it survive the scrutiny. So by having multiple scientists try to prove it wrong and fail to prove it wrong, now it starts to get closer to graduating to become what we would consider a theory. A theory, a scientific theory, is something that has gone through those trials. It's gone through peer review. It's had time to be scrutinized. It's not just like, I had some wild, crazy idea and everybody just accepts it. That's not how science is supposed to work. That's a little bit naive. So Alfred Wegener comes up with this idea, not in a vacuum. It's not like, how many times have you guys heard about scientists that came up with something? Umpteen times, right? And usually we celebrate that person, but what we sometimes forget is that they didn't exist in a vacuum. They weren't by themselves. Weren't they building on prior people's work, right? So Wegener is not all by himself here, but to take what we have for evidence and go as far as he did was groundbreaking. But he was early. He had no way to prove it.
This detailed map revealed one of the Earth's greatest secrets.
Okay, so in your notes to the side of where it says U.S. Navy sonar, right? Put this in your notes, sonar. Sound navigation and ranging. That's what it stands for. So how many of you all are fishermen or fisherwomen? A few of you? Has anybody ever been on a boat that has a fish finder, a sonar fish finder? So the way that the premise is, it's the machine sends out sound waves through the water, and those bounce back and will reveal the location of your fish. Or in the case of the U.S. Navy doing this mapping mission, they were revealing the depths. So like where are the trenches? Where are the ridges? Where are those undersea mountains so we don't run into them with submarines, whatever it is. But they were able to use it, like all of a sudden you can see these plate boundaries on the seafloor. So it was direct evidence that was indisputable. Yes?